James Carton. James is from Dublin City University. James is the Science Foundation and Assistant Professor in Sustainable Energy and Hydrogen in the School of Mechanical and Manufacturing Engineering. James is the Hydrogen Task Force Expert in the United Nations DCU, Hydrogen Mobility and Academic Advisor to the World Council and FEL alumni. James is also the chairman of the Hydrogen Ireland Association, looking to position hydrogen not just globally in Ireland, but making sure we avail those opportunities. Dr. Carton's aim as chair of the Hydrogen Ireland Association is to listen to the voice of its members and partners, to inform and share information with communities, industry, government and EU representatives, to support safe hydrogen technology development, demonstration of scale-up on the island of Ireland to achieve carbon emission reductions, to support the creation of hydrogen jobs and intellectual property, and to allow and enable Ireland to become a leader of hydrogen in Europe. James, I know what to transfer over to your technical control, so over to you, James. Thank you very much indeed.
Thank you, Paul. Thank you for the introduction, and it's great to be here today. And my presentation today is actually going to link in with the Republic of Ireland, but also UK and Northern Ireland, and the opportunity for Northern Ireland from a large scale energy storage point of view. So what I'm going to look at first is hydrogen applications and where the island of Ireland, because that's actually very important to mention the island of Ireland, because we do have a single energy market at the moment. We are connected, we are nearest neighbours, we do import and export to each other. And going forward, certainly for hydrogen, the relationship of north and south will be very important, as well as north with the United Kingdom. So I think what I'd like to kind of see first really is just kind of the applications for hydrogen going into the future. When are they coming, and what are coming for us on the island? So this is actually a graph here from Hydrogen Council, and they kind of dictate kind of existing hydrogen applications, new hydrogen applications. But actually, I kind of developed a hierarchy for Ireland from kind of what our island gives the opportunity around. And really, where we look at it, it's very similar to Hydrogen Council. I would look at that industry certainly has an opportunity for hydrogen, and actually looking at those industries that currently use hydrogen, that can use hydrogen, and if they exist on the island, they're the first demand that hydrogen should go to. And I think Thomas actually mentioned a really good point there, that producing all this hydrogen and the opportunity around production is only one side of the story. You need to see the demand and where it's going. And definitely that's an important thing when you're developing a low carbon society, when you're interacting with large amounts of renewables and thinking of wondering where the place for hydrogen is. So heavy transport, and it's great to see Northern Ireland's developing their heavy transport in the public transport sector, in buses and the deployment of it's more than trials. When you're getting to 20 buses, it's a deployment of hydrogen vehicles, and it's great to see a hydrogen bus manufacturer in Northern Ireland as well, that actually we can develop transport opportunities on the island again. And again, we see heavy transport, deploying out trials and small deployments at the moment, and by 2025 it should be quite normal. And then also heavy transport bringing in trucks and further deploying that in the 2025 scale will be very important. Heavy heat loads then, in relation to the industry that use temperatures for their processes in the range of 200 degrees or even plus or minus. That's the kind of area where heat pumps have difficulty. The only option is natural gas at the moment, and obviously that can evolve into hydrogen. Then gas grid obviously is very important, as Thomas said. The grid on the island is hydrogen rated, and there is a few modifications around safety and security and upgrading to your houses and buildings. But it's certainly that is an engineering problem, not a technical hurdle for any day in doing that. And then actually the regeneration of hydrogen back into electricity, and I'm going to talk a little bit about that in a minute. You know, that's something that, you know, really allows renewable energy to grow uncontrollably into the future, and it scales out renewable electricity, because now if we can understand that we can capture this excess renewable energy and then deploy that energy as electricity when the wind doesn't blow, the sun doesn't shine, that certainly is an opportunity for the Ireland, for the UK, and many countries across this part of the world where there's a lot of wind opportunity to deploy, and a lot of storage potential required. And I'll talk about that in a minute. And then direct electricity into fuel cells, directly electricity. That again is not a thing we should do today because we have other options, but certainly in the future, when we're looking at direct electricity through fuel cells, the expense will reduce and the opportunities will be there. And I like the way that Thomas mentioned in relation to oxygen. Oxygen is, if you're producing hydrogen from electrolysis, there's a huge amount of oxygen produced. And again, the wastewater industry, to develop that, to make it more efficient, to allow more waste to be processed in the one site. I think that's a huge opportunity. And again, we see that as today, 2021, as an opportunity. So again, I'm not going to talk much about the potential, but the potential of our republic, let alone the north, is massive. And I just wanted to kind of pull this together. And this applies to the island, the United Kingdom, Scotland, Northern Ireland. But you know, we're quite lucky to have industry, transport, electricity need. We have renewables being deployed. We have a gas grid, but we've also got a very educated and experienced workforce on the island. Again, that's very important when you're deploying technologies and creating that innovation. When you want the lights on, obviously you need renewables. But as I mentioned, you know, if you had some sort of extra renewables, and if you to avoid the overcapacity of renewables, possibly storage is definitely an option. And then obviously there's always an opportunity to fire that hydrogen to export, and that's again, it's a global opportunity, as Paul mentioned earlier on as well. So let's look at storage, and let's look at opportunities on the island for storage. So, you know, when you model or interact with storage for electricity, you look at the minute, the hour period mostly. And again, that technology is perfect. It's deployed, and I think that's definitely allows our electricity system to interact with a fast response with renewables and batteries. Once you go up to the hours, batteries become important, but batteries only have a certain amount. They fill up, they get full. When you have 2-3 days of lots of renewables, unfortunately the batteries are full after a couple of hours, so they can't fill up for the extra days or weeks that are there where there's extra renewables of wind or solar. So this then enables you to then opportunities around pumped hydro, compressed air, and then obviously hydrogen storage. And that's really what I want to talk about today. And I want to actually kind of give the idea of the type and scale of hydrogen storage that we're looking at. And you know, when you're looking at battery storage, in my head, certainly what I think is a field full of containers, and within those containers lots of batteries. And that's a nice idea, nice, you know, it's simple to think about. But when you think about hydrogen, you have to think bigger, way bigger. So to kind of do this, it's not just thinking about it, we actually run models with this in Dublin City University. And we've developed a model called Swiss 100 IE, and this is based on the island of Ireland. We've options on the Republic, and then an all-island model. And the idea really is to look at solar, wind, interconnection, and storage within the system. And we don't interact with bioenergy at all. We can actually interact with bioenergy, we can interact with nuclear, we can interact with lots of other stuff. But for this particular model that I show here, we don't. And we literally just, and for this idea here, we're just looking at electricity. So we're looking at this, and what you see really is, well, you know, the high spikes are offshore wind and onshore wind, the blue. The green on the top level is the storage required, and I'll look at that in more detail in a minute. And then on the bottom side, the black we'll say is electricity demand, and there's kind of storage moving in. And we have a little bit of solar in the yellow, but the blue is wind opportunity. So this is the problem with wind resources. In a period of time, like today, if you look outside, the very still weather we're having at the moment. This is due to low pressures or high pressures that come over the island, and that allows basically allows that there's very little renewable energy generated. So we need a lot of storage if we are to look at a 100% renewable system just running on solar and wind. So if we look at this, then we have, we've peaks and troughs here, and the green represents filling that in with actually hydrogen generated from combined cycle gas turbines. And again, the black on the bottom represents demand. Demand doesn't slow down just because it's a still day. So let's look at this a bit more focused. And what we're able to see with kind of that period of time, say in the February-March period, or over across the year, but what we're able to do with storage is that we're able to pull a lot of electricity in from the interconnectors into the island. And we're able to pull in about a half a terawatt hour of electricity from interconnectors into the Republic. But then obviously in February, March, if we don't have any storage of anything else, we're kind of we have to rely back on fossil fuels. So in our model, we looked at hydrogen store, and we're looked at in the range of, say, January, February, March, the area I was looking at there. We need in the range of around 1.5 terawatt hours of hydrogen storage. And across the year, and this is just for electricity, we'd need probably in the range of just over 2.5 or 3 terawatt hours of hydrogen, as well as the 0.5 terawatt hour of interconnection that is there, as well as the gigawatt hours that we get from the pumped hydro that we have on our system. So that was just electricity. So let's look at the entire Republic of Ireland energy system, assuming it's 2030. We've chosen a weather year of 2010, and we're looking at just wind, onshore and offshore, and just solar to actually supply the energy. And our demand is everything. So electricity, transport, heat, direct air capture. Actually, we're going to take some carbon out of the air as well, and we're going to facilitate aviation as well. And all we're going to use that to balance that is an interconnector, battery, and hydrogen gas turbines. So let's see how this works. So the numbers, it's kind of the shape of this graph is very similar to the other one, but the numbers are a lot bigger. So in total, we have 40 gigawatts of installed wind capacity on average. And we can see the colors there. So the black on the bottom side is electricity. The blue is surface transport. The turquoise is heating, gas heating, or heating. And then the rest of it then are the spikes in relation to the brown. The gray is direct air capture, for example. But actually, aviation is actually within that, but you can't see it. It's relatively so small compared to, for example, heating or transport electricity. So again, we're looking at a really difficult time of the year. So going into March, into April, where we have no wind, and going into April into May, we have lots of wind. So we can see that there's lots of hydrogen being deployed within combined cycle and open cycle gas turbines to supply electricity, but also a lot of hydrogen being pumped into the gas pipes to actually allow us to heat our homes and overcome the winter cool. And again, we can see if we move into April in this model, we have lots of wind in April. We're producing hydrogen and we're putting that to storage. So again, this is the same amount of storage we're looking at here. And what we can see is that overall across the country, we need about 8 to 10 terawatt hours of storage to basically decarbonize absolutely everything. Now our interconnector hasn't changed; that's still a 0.5 terawatt hour. And again, the reliance will fall onto hydrogen. Battery here is a grey line. You can slightly see it on the top line here, and it's really interesting to have batteries. But batteries, when they 3 to 6 hours is perfect. But when you're looking at a month of moving that months from April to May, June, or July, or from August right back to January, When you're moving that much of energy and storing that, that's going to be important, and hydrogen will play a huge role there. So that's really great modeling, but let's see, can we actually store this amount of energy? So we looked at this. This was a review done by our some colleagues that we've interacted with on the potential of salt caverns of energy storage. And we look at Ireland, the island, and we see that, well, the Republic has no salt caverns whatsoever. And more likely, their gas fields aren't suitable for hydrogen storage. They're really good for potentially putting carbon into, but not really good for hydrogen. So where there is high salt cavern storage is Larne, and there's a lot of it. And we did the maths with our colleagues, and we're going to be publishing this over the summer. But what the salt storage in Larne in Northern Ireland has is quite big. So when you look at hydrogen storage in salt caverns, it's quite straightforward. You melt out, you dissolve out a cavern with water. You process that salt so it's not damaging the environment, and you have a cavern left that's impermeable to hydrogen. And basically you make loads of them so that if you get any issues or subsidence or anything underground, you don't have any problems overall. But the theoretical potential of Larne is around 180 terawatt hours. That's actually the theoretical that's plausible and across the whole north east of Northern Ireland. But actually, as we're good researchers and scientists, we actually kind of pull in we get rid of half of that because some of that isn't actually the technical potential isn't too good on that. So we maybe say half that is within the regions we want, not near populated areas, in the depth we like, don't have stratifications on it, so there's no, it's clean and it's good quality salt. And then we look at the economic potential and the ecological potential. So again, we don't want to harm the groundwater, we don't interact with the sea, or we don't want to contaminate too much stuff on developing this. So if we have a blend there, we usually come in with a kind of a realizable potential. And the realizable potential for Northern Ireland is greater than 10 terawatt hours. This is enough storage that I'll just put here to actually allow Ireland, the island of Ireland, north and south, to run our entire energy system, which includes heating, our electricity, our transport, our aviation, and enough to kind of maybe even sell a bit to the rest of the world, to actually run our system on full renewables. It's quite amazing that we have that on the island. And actually, before I go, what I want to say is that this is really interesting for Northern Ireland, and this really sets Northern Ireland apart from the Republic and from parts of the United Kingdom. Northern Ireland has the opportunity to actually develop this, engage with this, and become actually the ballcock of the valve that stores hydrogen, supplies hydrogen to the regions in the Republic and in the UK. I think there's huge opportunity for that, and I think over the next 10, 15 years, this needs to be understood in greater detail, and it's a really interesting picture for hydrogen going into the future, and Northern Ireland being a really key element to hydrogen deployment between Ireland, Republic of Ireland, the island of Ireland, and the United Kingdom. So I'm going to leave it there, and I'm happy to answer any questions, technical or otherwise, from the floor. Thank you.
James, many thanks for that. There was a question from Juliana Steinbeck, and the question was, what is the best way to store hydrogen in Ireland? I think your last slide has answered that and has provided all the technical opportunities there. Can you hear us?
Sorry, Paul, I lost you there for a second.
Okay, Juliana's question was, what is the best way to store hydrogen in Ireland? And you've talked about the salt mines. In addition to that, are there other options that would be feasible or commercially opportunistic?
Yeah, sorry. So our model actually looked at steel containers, and we also looked at salt caverns. And I'm looking at scale here. We're looking at terawatt hours. So hundreds of thousands and into millions of tons of hydrogen stored. So that's the scale. So if you go down to small scale, obviously, for your cars and for your your mobility. Obviously, small scale storage is compressed hydrogen or metal hydride, chemical hydrogen storage. But actually, as you go to scale out from 2021 right up to 2035, where salt carbon storage probably is a reliable and potential economic opportunity at that point. But as we go from here to there over the next decade or so, we see that metal storage will be important initially. So you'll have hydrogen stored on site in tankers, being actually stored in the supply chain as it's moving from where it's produced to where it's delivered. Those tankers, whether they're in tankers or on road or on rail, or will be important. The gas grid itself is going to be really important. You know, we have effectively steel tankers dug into the ground, of a half a meter in diameter. They are effectively our initial storage point, up to the point where we decide that we just cut the umbilical cord of fossil fuels, and we have the technical feasibility of storage at scale, for example, in salt carbons. So I think there's definitely a kind of a 1, 2, 3 activity that needs to happen over the next decade. But ultimately, salt carbon storage in Northern Ireland is a huge potential for the economy of Northern Ireland.
Excellent. There's a question also from Nikhil Kumar Shah, is what is the realistic time frame to implement hydrogen to reduce overall CO2? As we need action now and not in the future, any measure in the future needs to be threefold. So what is the realistic time frame, please, James?
Yeah, so like, all my work is all about decarbonisation, and it just so happens that hydrogen fits in well with that story. So I think the urgency is paramount. So we should today deploy renewables. That's ultimately the thing we should do, because renewables, you can use electricity today to do things. You can decarbonize electricity system. You can decarbonize our heat system. A lot of our heat system with heat pumps. So electricity is important. Renewables are important. The issue becomes, as you get past that 70-80% of renewables on an energy system, it gets harder, more expensive, and you get more losses in a system as you try to get more renewables onto a system to get to 100%. And the idea for hydrogen is you never aim for 100%. Ireland will most likely produce, you can see from the scale of the numbers we're looking at, 300% renewables on our system compared to the energy we actually need. So the 200% isn't wasted. It's actually shoved back into the transport system, the heating system, the storage system, and it's exported. So hydrogen allows that to happen. It doesn't need, we don't need hydrogen today. We definitely will need it within the next decade. That's the funny thing. Within the next decade, we definitely need it. So I think that's what a lot of us researchers are doing, a lot of industry is looking at, is actually trying to build our skills, capability, and knowledge, and to plan for that transition. And this energy transition, Paul, is actually going to be the fastest energy transition that the world has ever seen. This is going to happen in the next decade, and if it doesn't, it's very disappointing for our children. That's what I'd say.
When you say this energy transition is going to be the fastest, will this energy transition actually kickstart a new industrial revolution?
Well, it is already. So Thomas talked about the Northern Ireland economy and the innovation and the jobs that are already there. Like, those jobs are only going to be an opportunity going into the future. Like, out of this pandemic, there are jobs in renewables, there are jobs in storage, there are jobs in innovation to actually solve some of the problems that the researchers don't bother solving. We don't go that deep. But we do need small companies. We need big companies to solve all these problems, and there's a huge economic potential there. The other thing is in relation to the skills, in relation to skills that these people are needing to get into this transition. That's actually going to be a potential bottleneck. And I think projects like High Skills, which has just been funded in the north of Ireland, actually allowed these skills to be developed and shared with the plumbers, the electricians, the mechanics of the future that will actually will be working on electric vehicles, hydrogen vehicles, putting in pipes that will be hydrogen rated. The safety requirement here is huge, and we must do it properly and safely. And there's jobs and opportunity around it.
Folks, there's a couple of other fantastic questions from Edagon Waters and from Wolf Clements that we'll keep to the panel questions at the end. So please do keep your questions coming. But one final question from you, James, is what companies are currently developing salt storage solutions that you know of across the globe? And that's from
so there's so NUIG, UCC, and DCU have pulled together a project called Highlight, and we're working with some of those countries in Ireland. And effectively, we'll be publishing some open source publications over the summer of the technology to companies that are doing stuff in this area. But certainly within the UK and Northern Ireland, there are companies looking at, there is salt carbon storage within the Northern Ireland at the moment. There's also salt carbon storage in the United Kingdom at Teesside, for example. And these companies are looking at it. Previously, we're looking at it for natural gas storage and are moving towards the opportunity around hydrogen. And again, within this Highlight project, we're to understand what companies are looking at it deeply. What are the opportunities? Because they all have the same questions. They're all asking, is hydrogen an opportunity? Is it going to happen? When is it going to happen? And at what scale? And I think from our modeling here, we kind of get to understand the scale. So we don't have to go to 10 terawatt hours tomorrow, but certainly having the capability that we build this over a decade or two to by 2040 or 2045 that we have that much storage, we could have a 100% renewable system developed on wind and solar by 2045 if you really wanted it, 2040 if you pushed it. So it doesn't have to be net zero by 2050. That's just a nice target, but we can pull that a lot sooner if we want to.
James, many thanks.